I would invite Atul to please introduce our keynote, Professor Martin Fischer. Please welcome Atul.
Good morning, everyone, and welcome to the second day of the Construction Technology Day and the CTI event. It's my pleasure to, reintroduce Dr. Martin Fischer. Mustafa did a great job describing Martin's accomplishments and what he has done throughout sort of his career. I feel like I have a very personal relationship with Martin, so rather than going through his accomplishments, I'll just maybe narrate a few things. So obviously, Martin, teaches at Stanford. He's the Kumagai Professor of Civil Engineering at Stanford University. He has also led for a long time the Center for Integrated Facility Engineering and is really considered the pioneer in the development, the theoretical underpinnings, and evolution of virtual design and construction. But I, sort of on the personal side, I was actually one of Dr. Fischer's PhD students. And one of the things I would say about him is, he's extremely passionate when it comes to really the growth and how to really improve the productivity, safety, and quality in our industry through the use of virtual design and construction. And the other thing I would say is he has given his time very freely to promote that throughout the world. So this is not just us. When originally we were discussing this idea of forming the Construction Technology Alliance Foundation, because of the infrastructure growth that is happening in India, one of the things I talked to Martin was, Martin, you have helped a lot of different countries adopt these new methods, and we would love to have your expertise and guidance in making that happen in India. And he was very willing to sort of do that, and I can attest to it. He is one of the persons who is always, wherever he is in the world, when we do the Construction Technology Alliance Foundation calls, he's the first one to join. And some of those calls, I think the core team here will tell you, are like 6 a.m. Pacific time in the morning. Wherever he's in the world, he'll try and make it a point to attend those calls. And this is not just, he's doing it just for us, but he's doing it for many other people that I know of. I can attest to the fact that, I was invited to meet and participate in a virtual design and construction program in Lima, Peru. And Peru is a small country, and you go there and you really see the impact of what they have been able to do with virtual design and construction. And I think, Martin, you're going to probably share an example of that on what a developing country can really adopt in really making huge changes in the way things can be delivered much more efficiently. Martin's also, I think one anecdote I was thinking about, he's a world traveler. I think, from here he's going to go to Montreal to participate in a Canadian conference. He's come from a couple different countries before he came to India. He's been here only maybe about 24 hours, but very committed to sort of promoting virtual design and construction worldwide. One of the benefits that, of his travel is, if you ever are in doubt and are traveling the world and want to find what the best restaurant in the world is in any particular city, you can reach out to Martin and he'll tell you where the awesome places are. But, I've been lucky to, obviously consider Martin my mentor. He gave us the opportunity to work with him on the book, which is Integrating Project Delivery. And I'm very happy. This is his second time actually participating in the Construction Technology Day event. He also graced us at the first Construction Technology event. So Martin, thank you for coming, and I would love to invite you to share some thoughts with the audience.
Thanks a lot, Atul, and it's great to be back, even if it's a quick trip this time. Have to find a better schedule next time. so I can visit more places. So it's my pleasure to share experiences that professionals like you have had, are making in various parts of the world, all enabled by technology. That was really great to see yesterday, the technologies and how they basically make us more efficient, more predictable, and ultimately more sustainable by integrating sometimes information across different silos, integrating information across phases, across different professionals, and then on that basis offering automated analysis, predictions, and so forth. So really enjoyed seeing those startups yesterday. Plus also the ones focused on hardware, on actual physical things. So that was also good to see. So let's see, I assume the slides will at some point come up. Yeah, so I titled my talk, State-of-the-Art and Future Methods for Managing Construction. I will share what I believe is the state-of-the-art method that I see used around the world to manage projects successfully, and then share what I believe we need to do as a community to take these methods to the next level. Yeah, it was a pleasure to collaborate with Atul, and we need to make an update, we know, on the IPD book and several other colleagues, where we outline how we believe projects should really be done to be successful. So what would a modern management method actually include? Of course, it would use the latest technologies, including BIM, etc., because you cannot really be successful on a project or in a company if you are not using, if you're not managing information well. But you also should include lean management thinking, principles, methods, focus basically on processes, because again, difficult to imagine a successful project where you don't pay attention to processes. You also need to include collaboration methods and tools, because at the end of the day, it's still us, the people, making projects happen, and we have to collaborate. And so we should really pay attention to how we collaborate, the environment we create to make collaboration successful. And I think finally, you would have a mindset around objectives, OKRs, as they're often called, and also really work with them to continuously improve your process. So you'd say, yeah, that's pretty obvious. I agree. The reality is that you find actually very few projects where all of these elements are put together and used consistently throughout all aspects of the project. And that's really basically the foundation of VDC. In VDC, we pay attention to the modern information management methods, and so we can visualize, integrate, automate. We pay attention to how we manage the production, digital and physical, on projects, how we collaborate. We call it integrated concurrent engineering, because when you have good digital representations, these days often called digital twin, you can parallelize or even make totally synchronous many aspects, many tasks on projects that in the past had to be sequential. And that's where dramatic time savings and quality improvements occur. And finally, of course, we have to make sure that we are clear on the project and objectives and the client or use phase objectives. And we are teaching this method. I'm not sure what's happening here, but so we're teaching these methods around the world. Let's see, the clicker has its own ideas of when it wants to advance. Let's see. Okay. Maybe by the end I'll find the magic touch of what I exactly have to do. So we're teaching this method to professionals around the world, above a group of Norwegian professionals, clients, engineering, architectural consultants, and contractors, and technology providers, and group in Switzerland, similar composition, and in Peru. So we're teaching this to professionals around the world. and then they implement that on project, and basically I will show a couple examples from these professionals. Is there any way to get like a better clicker or something? Sorry. Or does it need battery? Maybe you have a better touch.
Okay, it's like, you might want to, yeah.
So maybe I'll take a microphone and stand in the middle.
Yeah.
It's, I think, too far.
Yeah.
So, yeah. Okay. So the first example is from Peru, as Atul mentioned. This is really quite a remarkable project, even though it's a few years back. And basically, the key people on the project team had gone through this VDC education, and they said they were faced basically with almost an impossible task. The government had agreed to run the Pan Am Games, which is basically the Olympics for the Americas, in 2019. And in 2017, it occurred to them they needed to get going on building Olympic-level facilities. They had not a single Olympic quality facility in Peru, never been built. And so they said, okay, anybody here to sign up for this impossible project? And this basically company, Kosapi, said, yes, we can do it because we will use VDC consequentially from the beginning of the project. And so they designed and built, not just designed or built, they designed and built Olympic-level facilities for the games. You know, track and field, aquatic, all kinds of venues in 16 months. So this was quite a, I would say, yeah, quite an amazing accomplishment. Let's see, there seems to be a sweet spot, I don't know. So, well, they sorted out. You will see, I will very quickly illustrate basically all the aspects of VDC, right? How they managed the information on the project, brought the whole team together. Yeah, so this is basically 97,000 square meters of constructed area, basically all the main facilities and related infrastructure. And there was, of course, no opportunity to be late. So key part was, of course, the collaboration. And what was really quite remarkable here is that to start the project, they ran 52-hour so-called ICE sessions, really collaborative problem-solving sessions, not typical meetings where you walk away with a long to-do list. Sessions where different disciplines come together and actually resolve issues and move the project forward. This is a very different mindset, very different style of working. And they started the project with 50 of these sessions in the first 10 weeks to just rapidly advance key decisions. So it's, I think, quite a remarkable performance, and it's something we've seen around the world. When a project team basically improves the quality of decision-making by inviting multiple participants and supporting them with good information, and when they increase the speed or reduce the latency of decisions, projects get typically dramatically better. It's a little crazy that we don't do this more often. They used, everything was modeled in BIM, even a few years back, eventually at level 400. They had 60 models, 10 BIM users implemented, 3,000 issues solved during design and before to avoid construction impact, and 90% of the project staff worked regularly with BIM. So it was really integrated. It wasn't some sideshow, it was truly integrated in how the work was done. Because they had this immense time pressure, they didn't say, let's fall back in the old things. They actually really innovated. They took this as an opportunity to innovate. And of course, they carefully modeled all the production processes, including how to work together with the consultant, which was Arup in England that had just come off the London Olympics. So they provided the design, so they had to work between Peru and the UK. And they also used iSessions to design those work processes, just to illustrate. So you can see here illustrated just numerous sessions they had to make sure that everybody was agreed to the process and followed it, and to develop the metrics that they're going to track to see whether a project is on track or whether they need to change something. So this is just very quick glimpses to just hopefully bring to life a little bit the different elements of VDC. As I said, for me, it makes total sense to work to manage projects this way. But you find many projects where there's the focus on BIM or there's a focus on lean. The opportunity really is to bring all of these elements together. Second case I want to share is by Max. He's a senior project manager for Lidl, supermarket chain in Europe. They have quite many stores, and what you're seeing is his project to receive the VDC certification. He's basically head of all project management for Lidl in Sweden, and so they develop stores in all kinds of places to bring affordable groceries to the various communities. They were able to, in 3 years of deploying VDC from 21 to 24, reduce the construction cost by 45%. It's really quite dramatic. Okay, if you start in a bad place, then that's maybe easy to do. They had the distinction of being the highest cost country of all the countries. So you see in the histogram, each bar is a country and their average construction cost, square meters per store. And the Sweden managers were, of course, not happy to go to the headquarters in Germany and being recognized as, you're the most expensive place to build. Of course, the excuses came very quickly. Every store is, of course, unique. How can you compare a store in downtown Stockholm with a store in a outskirts of a small town? And Sweden is an expensive country, so of course we would be expensive. But the management didn't buy it anymore. So they said we have to do better. And so that's where they are today. So they moved in 3 years to that position. Not quite the lowest cost country, but one of the lower cost countries. I think it's a very remarkable story of, again, bringing the VDC methods with great intent and vision to their projects. So what they did systematically, they started to look for things that could be standardized, that could be simplified in terms of then also decision-making on projects. So of course there's unique aspects to every store, but there's also many aspects that are common. And so they really, and I think this is an opportunity for all of us to look for the common elements in project and sort of standardize them, make the decision-making process simple, straightforward, the information you're going to use, the feedback loops, all of that. It's crazy how many times we reinvent the wheel on our projects. So this is, I think, an opportunity we have for most projects. And so then a store can just say, yeah, the standard mechanical room is totally fine for us. Every new store has to start with the master BIM. So they have one master BIM that everybody has to start. It says level 350, so quite high level. And then they are expected to make improvements to the solutions or to the BIM itself. And so over time, they have been able to improve this master BIM. So the next store starts with an even better model. And again, this is something that I think that's really in reach for all of us, or for many of us, on many of our projects. And so you wonder, what's the effect? They are able to make 3 out of 4 decisions in 1 week. I don't know what your clients do, but I think most people will be quite happy with that. Almost all decisions within less than 3 weeks. And you might say, okay, yeah, you can make decisions fast, but then the point is not to change them. And you can see they only change 1 in 33 decisions. So they also have high quality decisions made really fast. You can imagine how just that by itself makes a project dramatically better. Of course, that wouldn't be possible without, the sound information and the streamline processes. They able to go to tender with a GC in about 2 weeks, so incredibly fast. And they've reduced the cost of design by 80%. And my designers might say, okay, I don't like that, but from a client perspective, of course, it's pretty awesome. Of course, they have to spend some money on maintaining this master model, which is actually less than they used to spend on maintaining the information that they would give out to bidders anyway. And the tender is done with a detailed bill of materials that the owner puts out, and they have seen a reduction in the variability on the bids from 30%, plus minus 30%, to plus minus 3%. So I think it's quite a remarkable success, I would say. And I think there's some things we can take away in terms of systematically bringing all the elements of the VDC method and connect them to your projects, and using them to look for things that are common across projects and simplify them, so that you can free up the time of the project team to focus on the truly unique elements and not basically reinvent new things, everything from on every project. So this is what I see companies being able to do around the world in terms of managing their projects and the improvements they've been able to achieve. So I think these are basically all it takes is a bit of leadership and attention, and staying the course, I would say. So what's next? As you've seen yesterday, and as you probably know, in the last few years, the ability that we have to collect data has really gone up dramatically. And what I mean by data here is data about how work is done. We never had that. And now this demands really a new way of conceptualizing our work. Because right now, basically, most of the processes we use are the way they are because they assume you don't have access to good data. But now we can have access to good data, so we should also rethink our processes and the underlying concepts we use. And I see that as the task we have together between academia and industry to develop these new methods. Because I don't think it's something that industry alone can do. It's also certainly not something academia alone can do, and that's what we really do in the collaboration we have at Stanford with the Center for Integrated Facility Engineering. So what does this look like? So basically the idea is to really improve the bottom part of the VDC framework in terms of visualization and project integration of information and managing the production. So as Srinivas from Pace Robotics said, one of the advantages of robotics is you get a lot of good data. And similarly, there's many other ways in which we can collect data on projects. So like one example, one technology we have been working with some of the contractors is Versatile, that gives you data every second of what the crane hook is doing, what the crane is doing. So you can see that, this gives you about 2,500 data points, depends a bit on how many lifts per day. Over a project of several months, it's a bit of data to look at. So we need, as I said, new methods to really leverage this data. And you can gain actually some quite good insights here, which my students have developed in my class. So this is results from a class project. For example, you learn we're comparing two different projects, two high-rise projects, 43-story condo towers in Honolulu, happen to be these projects. It's interesting to see how the cycle time for a crane lift changes over the course of a day, and is also different on project to project. Now you have facts, right? We can see the learning curve. Like every doubling of lifts, we see a reduction of 15% in the cycle time, even though you're going higher up. We see also again for rebar lifts, we see the cycle time coming down. So there's definitely learning curve effects on a project that we can now quantify. We saw that the cycle times on work a Saturday was dramatically longer than on other days. We're not quite sure why, but that was also interesting for the managers to see. On the other hand, when the overtime is after work, during the workday, then the cycle times are much quicker. So that was interesting for them to see the data. You can see what was a revelation for them is how much slower cycle times are before and after major holidays. They thought maybe it should be faster because people are anxious to get away, but no, actually the data show that you are paying about a 20% penalty roughly on the cycle time before and after the holidays. You can see that in the rainy season the cycle times are slower. That's kind of what they would expect, or higher. They could also see that when you have consecutive lifts at the same time, there's less idle time, so you're using the crane much more. When you switch between different kinds of lifts, and this idle time goes up. Of course, you have to do some switching, but this really was also insightful for them to see how much penalty there is when they keep switching the lifts. So anyway, I think you get the idea here. I think this is the most clicks I've ever done for a presentation. Can you go to the next? For a while we were doing okay, but now, okay. Maybe I should, yeah, let me just, I think you get the idea. There's a few more examples, but I'll just move on to basically the method we need to develop. So I think you get the idea. We can get, like, from the data, lots of insights that the team finds very valuable. But these are just sort of punctual insights, which are good. What we really need to do is we need to develop a method to manage projects with the data. So we're able to do that on a parking garage, just prototype a method to support the daily look-ahead planning for this precast company. And as a precast company, right, you sort of live and die economically with ordering the right number of parts to the site the next day. Because you have to install them directly from the truck because you don't have space or time or budget to unload them, find them again, and install them. And so you need to, the day before, decide how many parts you want to install tomorrow, otherwise you pay overtime or you waste capacity. So how they do it today, they look basically at average duration per installation of a part at the end of the day, and they say, okay, tomorrow maybe similar or a little bit faster or slower, and based on that they order the parts. On average, with this method, they were 2 hours off. This is a really, really good company, but they were on average 2 hours off each day. So you can see this adds up over the course of a project. And so then we were wondering, if you used this detailed data just to manage a project every day, could you do better? So what you see here, I know it's a little bit of a crazy chart, but so here you see how many parts they ordered, which is the gray dots each day. So on these days they did quite good because 0 means 0 overtime and 0 wasted capacity. So ordered exactly the right number of parts. And you can see that on other days, many days, they were pretty far off with the parts they ordered. And what you see in color is using the detailed data every day to order the parts for the next day. And on average, most days, they are significantly better predictions, as you would expect, for the work that should be done next day, that can be done next day. So it's kind of what we expected, but it was good to see actually confirmed. But we had to actually develop, right, a tool that did the look-ahead planning for the next day fully automatically, because you can't possibly sift through thousands and thousands of data points by hand. And so basically we're able to reduce the forecast error by 50% and automate the planning for the next day. So giving somebody on site 2 hours off or 2 hours to do something else, going home 2 hours early or something. So I think this is what we have to do. We have to develop digital twins, production twins for our work, not only on site or in the factory, but also in design. So we have to have a production system mindset, setting objectives, mapping the production processes, but not just to visualize them, to really connect them to a computational simulation that can use the detailed data we can now collect. So I see that as really our task ahead. So hopefully, oops, there's my timer. Sorry. Yeah. So I see, depending on where you are, my recommendation is that you should manage your projects using VDC methods. Because it's also a framework that allows you, as you could see, to bring in these modern ways of really leveraging the data so that you can get true sustained value from the data over time. So I look forward to collaborating with you on achieving this vision.
So we're going to have a conversation with Martin, and one of the things that I talked with him about is, I want you all to be thinking about the questions that you want to ask him. So the first 3 people that are going to ask the question, we're going to send a book to them, the Integrating Project Delivery book. Okay, so I'm going to first ask a few questions, and then we'll have you guys think about that. So please be thinking. So maybe before I start, Martin, I want to just gauge sort of, who's in the audience. So raise your hand if you are a provider of technology, either building products or services to the construction industry.
Well, it's almost everybody, huh?
That's almost everybody. And anyone in academia? There's a few. Anyone in the design industry, architects, engineers? Yeah, so it's a good mix, Martin.
Mm-hmm.
So, yes, but let's start with. We saw some really awesome startups yesterday, and you saw that many in the audience are either building products or providing services, and the theme that at least I picked up on was, they're doing this to either add predictability, or make the process sort of more efficient. But one of the things that we also sort of picked up on is, what clicks? Like, have you seen some good examples of how the people here can really serve the industry better or penetrate or, the customers that they're trying to serve?
So I think the technologies that really improve the predictability or reliability of work, I think are absolutely key, because I think that's the foundation for all the improvement. If we do not make that improvement, then a lot of the other technologies, we will not see the full benefits, because we have to reduce, to the extent possible, we cannot totally eliminate it, but we have to reduce the variability in execution, duration, effort, quality. And we have to pay attention to that on site and in the factories. So I see why I say this is because we should not lose sight of the core thing we have to do. We have to get the projects built. That's when they serve the public. And it's good to pay attention to the administrative processes and other aspects of the project, but I think it's most important to focus on the use of technologies that improves the predictability of the work on site and in off-site factories. I would say, I know it's kind of a general answer, but that's what's fundamentally needed.
Thanks. So Martin, we heard the rapid sort of growth of infrastructure in India over the last 10 years. I think Mr. Weber was, sharing some of the statistics with us, just the electrification that has happened with railways, all these other things that are pretty dramatic to see, in the country. But you've traveled all over the world and, worked in developed and developing countries. Is there something that India can learn from other places that you think we should adopt?
So for one, I hope you will leapfrog as you have done in other sectors and with other technologies. The slow adoption of technologies that you see in the developed world, because we went through the process, still kind of going through the process of bringing advanced technologies to analog processes, which sometimes for me is a bit of a paradox. And you should hopefully just jump over this and create data-driven methods of managing the infrastructure. I mean, they're just amazing and formidable infrastructure projects you have. Truly data-driven methods, right? So that's just, I know that's not directly answering the question. A place where I saw really, where I see the most innovation in this field, especially in infrastructure, is in Norway. And I understand it's in a very high-cost country, but they have very complex and large infrastructure undertaking. It's quite amazing the kind of things they're trying to build there. And they have done, I would say, a couple changes that you can see whether they make sense here. For one is the large public infrastructure clients for several years now have basically demanded or are demanding in their request for proposal to potential bidders or providers of services and construction that the project be managed with the VDC methods as we have defined it. Not some version of VDC that somebody says, this is my version of VDC. No, with the VDC method that we have defined it, with the collaboration, with the use of BIM, with the pay attention to the lean methods. So basically the client leadership, I think, has really helped transform the industry. You saw the huge crowd of professionals there. There was 1/3 owners, 1/3 designers, 1/3 builders. It was, and they went through an educational experience together. Because on a project, we all have to work together to make it successful for everybody. So that is one thing they've done. The other thing they have done is they were tired of the finger pointing between designers and builders. The designer saying, you hired a stupid builder, Mr. Owner. If you hired a good builder, then they could build my design. And the builder saying to the client, well, you created a design that can't be built. Like, what do you want us to do? And they didn't know who was correct. And they said finally, okay, there'll be enough of that. So what's now happening on infrastructure projects there is the owner hires the contractor right away, and the designers are working for the contractor. They're saying, at the end, it's about the built product. Of course, we need to design, but it has to be buildable. Of course, it also has to be usable and operable and sustainable. But we don't want to get into these arguments like whose fault it is. You work for the contractor, so contractor, it's your design. If you can't build it, don't look to us to give you more money because you can't build what you designed or your designer designed. So there's a couple, I think, quite interesting changes. I mean, they've also done some projects, everything in 3D, no paper, no 2D, nothing. Everything digital, everything 3D, that have also shown that is entirely possible today.
So Martin, one other question, and I think after that I'll maybe open it up for the audience questions is, I think coming from sort of Silicon Valley, I think we talk about the industry, academia, the venture capital community. It's a sort of a very symbiotic ecosystem that has spawned a lot of really creative solutions in the technology space, in other spaces. And I think Aditya mentioned this yesterday when we were talking about sort of a place like Bangalore. It's sort of starting to come together. I mean, what you see, so this is your, I think, third trip to India, and sort of, what creativity do you see here? What else would your advice be to sort of, continue to grow that ecosystem so we can have that sort of vibrant sort of creativity helping the construction industry?
I mean, I have to say it's quite remarkable, even in the 2 years since we had CTD 1 in Pune. The sort of sense I get from talking with people is, modern way of designing, building, operating buildings, infrastructure, has arrived or is pretty much here, right? Where the conversations were, I guess I should have thought of a good way of summarizing it, but there was sort of the idea, I felt, 2 years ago, but now it feels like, these ideas have arrived. We saw it just with the number of startups. And so I think the improvement in sort of mind share and tool set is quite remarkable that I see in 2 years. So it's quite amazing. As you know, I'm a big fan of really quite close collaboration between industry and academia. Because in industry, construction industry doesn't really have R&D money, or not a lot, but it's also crazy that we don't do more R&D. We treat often you find that you treat a project, it's like the last one you ever do. Then the behavior would make total sense. But it's not the last project we're going to do many more. So so when you have an academia-industry collaboration, what I find is industry challenges us in being practical and thinking about what's the impact of what we need to develop, and we challenge industry to be conceptual. And I would say this is more important than ever, because if we put all of this data that we are starting to use into our industry in the absence of sound concepts, sound theory, we'll just create a big mess. Then we really need a lot of AI to sort it out. And I think that's where the collaboration I found just valuable. I don't know how I could do my research without industry, and hopefully industry feels sometimes also inspired and challenged by us. So to the extent that this kind of collaboration can also be set up in India, I think it would benefit everyone.
Yeah, and I think that's the goal of the CTI Foundation, and I mean, the fact that we are at IISc and we were at IIT last year is a testament to that. So anyway, I'm going to open it up for questions. So we'll start with Mr. Vaibhav, then we'll go here, and then Shabbir will come to you. I think if somebody can get a mic, yeah.
Thank you, Martin, for a wonderful presentation. I was just wondering, as you said, VDC has helped companies to not only reduce the wastages, both on time and resources, improve on the delivery times, and ultimately reduce the cost of production and faster deliveries. You also mentioned that Norway is trying to kind of make it mandatory or regulate to make sure all projects are using VDC in some or other formats. Are there examples where other nations have made it mandatory to do that VDC, or in your experience in US or some other places? Because these are some, for example, BIM is by and large accepted in most of the countries now, like even in India. But I have seen particularly in the infrastructure project, the regulatory framework helps bring in technology or methods more faster than the initiatives by the contractors or designers on their own. Because since most of the infrastructure projects are public projects, and government agencies are agencies which normally regulates the whole process. So what's your experience on that?
Yeah, so in the US, we don't really believe too much in government regulation. So these things tend to happen more from companies, although there is now some advancements in the AASHTO, the federal agency for highways, and several departments of transportation to finally move into the 21st century, I would say. I haven't seen another country quite to the level of Norway. So BIM in most countries like UK, Chile, Peru, many other countries, the focus is on BIM, which I would say is good, but not enough. So I'm not saying we should not do that, but information management is just part of project management. Maybe we can brainstorm and think how we can get those governments to recognize, yes, having some regulations, having some expectations about BIM is good, but we can also be leaders in promoting a truly useful use of BIM, move towards VDC.
Yeah. Professor Martin, thank you very much. Very inspiring, VDC. What is running on my head is, Whatever we discussed is all about information and the methods of managing the project. But the physical side of creating the building, be it by building manually or by prefabrication or precasting or printing, how much of technology has actually come in? We talk about design for manufacturing and assembly of building, DFME. We got about platforms for DFME. We gone there. But how much do you see in your global exposure of the new technologies that have come in to remove the manual work? Manufacturing, one of your parking lot stuff, did give us a feel. We believe in India, considering the size, scale, scope. One example, we are one country, we talked about 30 million houses to be delivered in 1,260 days, which is a 10 million square foot a day of production. That's the scale and size we have. Hence, we are very, very keen. Which one do you think, from your the high view, is the best for a country like ours, not only for infra, for the superstructure as well?
Yeah, so what I find is still very good in this respect, and the technology that has really arrived is the continuity of digital information at a high level of detail or development that you find, I would say, in California and on the West Coast, and a few other parts in the US, but maybe a little more prevalent to find on the West Coast, where it's pretty much expected that the subcontractors participate in the design process, in the detailing process, work in 3D, coordinate in 3D, take the 3D data, fabricate from it, and help manage the project in terms of how it comes together. So this practice I still don't see has arrived to this level in many parts of the world. But in California, if you're building in concrete, the rebar, the concrete, if you the steel, the facade, many parts of a building, mechanical, electrical, piping, fire protection systems, all of those systems are basically done with a process like that in any kind of good-sized building. So I think this is technology that has arrived and is well established, and you can probably imagine already has many benefits. Where I'd say we need to make some improvements still is in bringing sort of knowledge about what is easily fabricatable, what is easily buildable back into the design phase. So we can, from the beginning, it happens on some projects, but not, I wouldn't say I don't see it as systematically. And I think that's where we could also use some better technologies so that we can do truly DFMA, right? Let's see. So, I think that's one of the practices that I like, and I think is a really solid foundation for advancement. The other, when I see technology, I would say, if I reflect, when you see people and technology really coming together, is when a client or project team early on in the project puts all of the expectations for the project on the table, not like sequentially discovers them, right? And then designs the building or whatever they have to design, the infrastructure, and how to make it concurrently. So for example, like in Peru, right? We have to finish in 16 months. So that becomes a critical time constraint. And all the conversation is, how do we do it? What do we have to stop doing because we cannot afford it? What are the new things we have to start to do? Right? So that's what I mean. And I'm surprised that we don't see this approach to managing projects more often. I guess everybody is just so afraid of being able to show, afraid. Everybody wants to show we got the lowest cost, but you got the lowest cost for not necessarily the best design, and unlikely the lowest cost by the time you open whatever you're building. So that's a practice that I would say we could use a lot more, which I think basically demands leadership and then good people, but you have good people. And so I think it's a question of leadership.
Shabir.
Hi, Martin. Good morning. This is Shabir here from Slabs Engineering, and we are into precast construction and engineering as well. So it's been like more than 15 years. We are into precast industry. I was working with Arup before. So I very much correlate with you. You said that, using BIM, we reduce that margin of 30% to 3% in regards to the bids which we got from the suppliers. We have also, realized that on all our projects. The second part I wanted from your side is, we are working with several clients globally for precast industries. So how did you capture the data when you talked about digital twin, bringing the processes and mapping it in production and erection? How did you map the data? Like, how did you get the data from the production team? That how many panels are erected and lifted by the crane? You use some sensors, or was it manually, observed by the team and given the data to you? Or
Yeah, nothing manual. Everything sensor. So it's all IoT sensors, either that are embedded in the machines or some other way. Sometimes a bit of computer vision, and then extracting the data you want from there. Yeah. So this way I find, there's still gaps in the data and some outliers, but relative to manual entry, it's a faster and is still much, much better. And on that basis, I think you can start to develop some AI type approaches of interpreting and making sense of the data. But what we found, we are working with a tool from Project Production Institute, Production System Optimizer, which allows you to create a computational process map based on sound principles from operations research, which basically have been applied in factories, which were kind of crazy to think about applying in our industry until now, but now we can get the data, so it's crazy for us not to use those methods, I would say.
so have you tried something on, hollow core slab production or wall panel production, slab panel production at the factory level, and then understand the data analytics of it?
Not that specific, but other kind of production in not that exactly that kind of product, but other kinds of products in factories. Yes.
Thank you.
So we'll take maybe two more questions.
Yeah, good morning, Professor Martin and Mr. Atul. So basically, I was very much interested to see a lot of savings on cycle time and efficiency improvement, because I come from contractors background. So I see a lot of pockets of excellence and a lot of inefficiencies. So my question is more related to that. So how do you see this integration of VDC evolving to address sustainability and efficiency challenges in large-scale projects? Because large-scale projects are order of the day.
Yeah.
So how do we see that to be sustainable over a long period, and it gets rolled over to one project to another and keeps progressing?
Yeah. It's at two levels, and I was torn whether I should put some slides in there. But it's at two levels. It's sort of in the VDC framework at the top, in the setting of the objectives, and there, to think about the economic, environmental, and social top line and costs, so we get a better bottom line as objectives, right? To challenge the project team to achieve them. And then the second place is in the execution of the project, you get much faster and complete feedback loops on how things are going. So you're learning much more quickly, and whether your work is wasteful or not, and then you can intervene when you still have an opportunity to change things, because you get the feedback much faster. So I would say those are the two places where I see VDC has helped companies become more and projects become more sustainable.
Okay.
Hello, Professor Martin. This is Nitin Gupta. I'm an architect. From your experience around the world, I just wanted to know how much of, in your opinion, how much of AI and automation is being used in the detailed design and engineering process around the world?
Yeah, there's a lot of people working on an AI in design. I would say we should be a little cautious with that at the moment. I think more promise still in parametric design, in leveraging the computational power to explore many options, and then maybe use AI methods on that data generated. to figure out what is best and how does it compare to other projects. I'm a little skeptical of using AI to make sense of past projects and find good solutions, because I'm not aware of a single company that has labeled its past projects and said that was a great design because, that was a bad design because, that was, and so if you don't have that data, what is the AI learning, right? Then I'm a little worried that you're just using the AI to to efficiently repeat okay practices. I don't want to say bad practices, potentially bad practices. Maybe you're lucky and you had good practices. So I'm a little bit skeptical in that way of using AI. If somebody disagrees, I'm happy to discuss and change my opinion. Sure. But I see right now still more opportunity in using the parametric methods, because for many aspects of design, not for all aspects, for many aspects of design, we have equations. So we don't need to use AI to discover the equations we know. We can just use the equations and apply them more quickly, and then maybe use AI to make sense of the
It could be rule-based also, so you need not depend on the past data only.
Yeah.
Right. Okay, thank you.
Yeah, so we are going to unfortunately have to cut it there. Mustafa is otherwise going to throw us out here. So I know there's going to be a break, so we'll continue those conversations. Thank you.
Thanks for all the questions. Great.